Okay, so the third and last question is going to be about a situation where a bar, you can see that this bar is connected at the point O, not in the end, is going to be connected first at the chord, and this chord at A is going to be suddenly cutted, and the bar will swing down to the value of the theta to be equal to 90 degree. If you want to know what will be the reaction at the point O, or the OX or the OY, or X and or Y for this situation. And also we need to know what will be the value for the alpha for this situation. So just remember that to find the reaction here, we need actually to do the same process that we done last week. We need to build the energy the do the kinetic diagram and the free body diagram, and we try to find a relation to find the forces at the point O. So to do that, we need to find either the omega or the alpha. We don't have either. We know that the omega 1 is equal to 0, but we don't know what the omega 2 is. And we start to do the calculation for this situation. So start first by applying the energy conservation energy, the equation for this one. We need to find the T1, the V1, the T2, and the V2. You have to know that actually in this scenario we're only going to have the weight going to do the work, so the V1 and the V2 can be found. The first one is going to be 0, the other one is going to be the weight multiplied by minus 0.2. So this will be easy. We just found the value for the V's. Now for the value for the T1 and the T2, we need to find the IG first, and then we're going to apply the equation uh, to have it in the form of the omega. The omega 1 is 0, so the T1 is going to be 0, the T2 is going to be in terms of the omega, and thus I'm going to be able to find the value for the omega. Later, we're going to apply the free body diagram to find the reactions on the x-axis, the y-axis, and the moment around the point O. To do that, we need to apply the kinetic diagrams. The answer is going to be alpha is 0, the omega is 6.48, and the xo is 0, and the oy is going to be equal to 91.1 Newton. So we are going to find first that we have the rod undergoes a rotation about the fixed axis through the point O. The equation of motion can be used to solving for the x direction reaction at O and the y direction reaction at O. And the omega, when the rod is swing down to theta is equal to 90, will be involved, and the easiest way to mine the omega is going to be the work and the energy method in this problem. So once again, this will be my free body diagram for the state 1 and the state 2. So you can see that the point G will be drawn by the value which is equal to the distance OG in the y direction negatively. That will be the delta y. And in this position at the beginning, we know that the omega 1 is equal to 0, but we don't know what the omega 2 in the second situation. So we are going to sketch also the free body diagram and the kinetic diagram. So this was the free body diagram in the position on 90 degree. The weight is going downward. The reaction at the y direction at the O is going upward. And for the x-axis, the OX going to the right. And the kinetic diagram, we're going to have the AGY, the mass multiplied by the AGY, where the AGY is going to be the normal acceleration, or the omega square multiplied by the R, and the tangential acceleration is going to be the AGX, or the MAGX, where we're going to have the AGX going to be the radial or tangential acceleration, which is going to be alpha multiplied by the R. And finally, we're going to have the alpha, which is going to be to the counterclockwise direction. So we're going to set the known, which is going to be the mass. The omega 1 is 0, the theta 1 is 0, theta 2 is 90, and we need to find the omega 2, the OX, the OY, and the alpha. So we start with the equation first, the energy conservation energy. The equation of the conservation of energy. So the T1 plus the V1 equal to T2 plus the V2. We should know that only the gravity force does work, and we're going to find the value for the omega 2. Then we're going to substitute in these three equations to find the OX, the OY, and the alpha. So we start with step number 1, find the Ig, which is going to be, of course, half of 1 over 12 ml squared. And we know the mass, we know the L, and we can find the value to be equal to 0.2667. Now we start to do the calculation. That's the T equation, half of the M mass multiplied by the Vg square, plus half of the Ig omega square. Well, the VA, of course, is going to be equal to 0.2 omega, and thus the equation can be rewritten by replacing the Vg by the omega multiplied by the R G slash O. That's all. Okay. Plus half of the Ig omega square. Now we're going to find the T1 and the T2. T1 is going to be 0 because the omega is equal to 0 at the state 1. The omega 2 is unknown, but we're going to write it down in this equation. Substitute the R with the 0.2 and the Ig with the 0.2667, and we will come out to the value of 0.233 omega 2 square is the value for the T2. Now we come into the work done by the weight. So the V1 is going to be equal to the weight multiplied by the Y1, and the V2 is going to be equal to the weight multiplied by the Y2. The Y1 is 0, so the V1 is 0. The Y2 is minus 0.2, and we can find the value for both V's. The first one is 0, second one is negative 9.81. Now we're going to put everything in the equation of the energy conservation, and we will find out that the omega 2 is going to be equal to 6.84 radian per second. That's it. Now we finished with the first solution. Now we are going to put everything to the other equation by using the free body diagram and the kinetic diagram. So the equations are going to be, first calculate the IO, because rotation is going to be around the IO. It's going to be equal to the Ig plus the mass multiplied by the Rg to O square, and this will give me the value to be equal to 0.4467. The AGY is the normal, the omega square multiplied by the RGO, and we'll find it as 8.398 meter per second square. The AGX is going to be 0.2 multiplied by the alpha. For the x direction forces in the free body diagram, we have the OX, and in the kinetic diagram, we have the MAGX. All is going to be equal to alpha because it's 5 times 0.2, which is equal to 1, so it's going to be alpha. The y direction forces is going to be the reaction O at the y direction minus the weight, and this will be equal to the mass multiplied by the acceleration to the y direction. So the OY is unknown, the weight is known, and the AGY is known, the mass is known, so I can find that the OY is going to be 91.1 Newton. Finally, we are going to come to the moment around the point O. It's 0. You don't have any force in the kinetic diagram. Okay, no moment going to be caused by any force at the point around the point O. So we will find that the Ig alpha is equal to 0 or the alpha is equal to 0. That's it. It's very simple. It's not complicated, but it's quite simple equation. You only need to know what to find and how to find it.